So sometimes retro projects go on for a long time. So this is kind of a discussion of one of those. I acquired a VT50 terminal, a DEC VT50 terminal, about 2.5 years ago. I've been sort of working on it since then. I've started to get more serious to fix it because it takes up tons of room. I'll show you in my little work area. You can see it kind of all spread out over there with the terminal, the schematic on the computer, and trying to get it to work. Hopefully I will, but not yet. So I'll show you a little bit of what I've found out.
So after a couple of years of nothing other than fixing chips, I did get it to show junk on the screen, so the character generator is working, and I have made some progress of connecting it up through RS-232. You can see the little green board. That's the RS-232 board that connects through, and I can now type on the terminal if the settings are right and have characters show up on my computer. So this is great. You might be wondering why I have this odd setup, but this is very difficult to work on in the case. So here's some pictures of the disassembly in the case. So I sort of figured out a way to splay it across a desk and put the video circuitry in a vise on a table with the CRT. So that actually allowed me to work on it.
So what was I fixing? First off, when I got it set up on the table, I checked all the power. It looked good. You want to check the power, because the power supply is like a pretty big transformer. It's all linear here, and going into a lot of big scary capacitors, but that all's working. Looked good, no problems there. So then I focused on the memory, because there were static memory chips, 7 of them on the board, and I dug in and tried to make sure they were behaving. I actually found a few of the address lines were bad, so I tracked down the chips that were not working.
So I ended up socketing all of the static memory. There are 2102s, which are kind of notorious for failure, at least in my TRS-80 experience. And here's one of the address line chips that was bad that got replaced. So memory looked okay. One cost-cutting measure in the VT50 and 52, as I understand it, is they didn't label the chip. So I had to go through with pencil and mark these off from the schematic, which took me a while. I wanted to mention that. So that's why the kind of pencil handwritten chip names are on there.
So next, I went on a bit of a diversion to kind of follow things from the keyboard. And this, I ended up replacing a chip on the keyboard, but I didn't need to. I, at the time, just did not understand how it works. It sort of goes through polling, and then there's like a special setup where when it reaches the end, it gives a signal out. And that looked like possibly a bad chip, but it was actually working as intended.
Okay, so here's the chip I ended up replacing. There was nothing wrong with this. The keyboard's kind of interesting because I did pull this completely apart and cleaned it. You can see that it looks pretty clean. And you really want to do that, blow it out, and check all the switches. And I did verify that all the key switches work and are just fine. So it sort of stuck for a while, but then I bought this little card on eBay. This is actually for a VT50. You can see VT50 on this, just in between the first and second line. Is the RS-232 connector. So this kind of was great to help me get a little bit farther with working on this. See these poles, that's what it attaches into. I'll just hold it there. And then you switch from the 20 milliamp current, which is what it's got built in, to the EIA, which is RS-232. With this card in place, I was able to hook it up to a PC and use PuTTY to actually communicate it with it. And I showed at the beginning that I'm at the point now where I can type on the VT50's keyboard and have it show up on the PC. So one mystery I did finally solve, once I got the screen sorted to show garbage, was what this weird switch did. It actually turns a power line of 12 volts into the Signetics 2513 character generator. When it's off, you just get like blocks of no things. When it's on, you get characters. I have no idea why this is on here because I would think this chip would work the same, but it's a mystery. So when I found a bad chip like E36, how did I replace it? So I clipped all the legs with a good cutter at the very top, so I have each individual leg, and then I use a soldering iron and tweezers, and I hold the one leg with the tweezers and heat up the other side. So when it warms up, I can carefully remove the individual leg. Once I have all of them out, I quickly, use a little bit of the solder sucker to clean up the other side. But then I put the socket in there and use the soldering iron again, trying to minimize heat and pressure to not damage the board, which is very fragile. All right, so I'll finish up. Still doesn't work, but I'm slowly going through the chips with the logic analyzer and figuring out what's working. This board has no microprocessor. I didn't mention that, but it sort of is the ROMs, which are in this picture underneath the little logic analyzer block there, on the right-hand side of the picture. They run sort of the discrete logic. It's like the inside of a CPU. It's decoding microcode, and that's how it executes the terminal memory storage and how it pulls the keyboard. Because the RS-232 outworks, I think that's the ROM's good, and some of the instructions are working, but not all of them. Obviously, the reading data in and showing things on the screen, that's not quite right. So more soon, and thank you for tuning in.